Learn physics at home. Chapter 1 Electric Charges and Fields Part 3. കഴിഞ്ഞ വീഡിയോയിൽ ഏതൊക്കെയാണ് ഡിഫറെൻറ്റ് മെത്തേഡ്സ് ഓഫ് ചാർജിങ്, എന്താണ് കണ്ടക്ഷൻ, എങ്ങനെയാണ് ചാർജ് ഇല്ലാത്ത ഒരു വസ്തുവിനെ ഇൻഡക്ഷൻ വഴി ചാർജ് ഉള്ള വസ്തുവാക്കി മാറ്റുന്നത് എന്നൊക്കെ നമുക്ക് മനസ്സിലായി. Let us recollect induction once more. What is induction? It is the method of charging a body under the presence of a charged body. ചാർജ് ഇല്ലാത്ത ഒരു വസ്തുവിനെ ചാർജ് ഉള്ള ഒരു വസ്തുവിൻ്റെ പ്രസൻസിൽ ചാർജ് ചെയ്യുന്നതിനെയാണ് ഇൻഡക്ഷൻ എന്ന് പറയുന്നത്. ചാർജ് ഇല്ലാത്ത മെറ്റൽ സ്ഫിയറിനെ പോസിറ്റീവ്ലി ചാർജ്ഡ് ബോഡി ആക്കി മാറ്റണമെങ്കിൽ നമ്മൾ ഒരു നെഗറ്റീവ്ലി ചാർജ്ഡ് ബോഡി ചാർജ് ഇല്ലാത്ത മെറ്റൽ സ്ഫിയറിൻ്റെ അടുത്ത് കൊണ്ടുചെല്ലണം. Then the charges are induced in the metal sphere and they are called induced charges. In the next step, what we have to do is we have to ground it and then remove the charge rod. Finally, we can see that the metal sphere is charged positively. അതുപോലെ തന്നെ ചാർജ് ഇല്ലാത്ത ഒരു മെറ്റൽ സ്ഫിയറിനെ നെഗറ്റീവ്ലി ചാർജ്ഡ് ബോഡി ആക്കണമെങ്കിൽ ഒരു പോസിറ്റീവ്ലി ചാർജ്ഡ് ബോഡി അതിൻ്റെ അടുത്ത് കൊണ്ടുചെല്ലണം. യു ക്യാൻ സീ ദിസ് ഓൾസോ ഇൻ ദ ഫിഗർ. First, we have to bring the positively charged rod near to the uncharged metal sphere. Then the charges will induced in the metal sphere. In the next step, what we have to do is we have to earth the positive side of the metal sphere and then remove the charged rod. And finally, we can see that the metal sphere becomes negatively charged. Okay. ചാർജ് ഇല്ലാത്ത ഒരു മെറ്റൽ സ്ഫിയറിനെ ഇൻഡക്ഷൻ വഴി ചാർജ് ചെയ്തതുപോലെ രണ്ട് മെറ്റൽ സ്ഫിയേഴ്സിനെ ഇൻഡക്ഷൻ വഴി ചാർജ് ചെയ്യാൻ പറ്റുമോ? അങ്ങനെ ചെയ്യാൻ പറ്റുമെങ്കിൽ എങ്ങനെയായിരിക്കും ആ മെറ്റൽ സ്ഫിയറിൽ ചാർജസ് ഉണ്ടാവുക? സെയിം ചാർജസ് ആണോ, ഓപ്പോസിറ്റ് ചാർജസ് ആണോ, അതോ ഈക്വൽ ആൻഡ് ഓപ്പോസിറ്റ് ചാർജസ് ആണോ എന്ന് നമുക്ക് നോക്കാം. ഹൗ ടു ചാർജ് ടു മെറ്റൽ സ്ഫിയേഴ്സ് equally and oppositely by the method of induction. So for that, first take two metal spheres A and B and keep them in contact. Aക്കും Bക്കും ചാർജ് ഇല്ല, പ്രത്യേകം ശ്രദ്ധിക്കുക. They are in contact, they are in touch with each other. In the next step, we are bringing a positively charged rod near to it. ഒരു പോസിറ്റീവ്ലി ചാർജ്ഡ് റോഡ് മെറ്റൽ സ്ഫിയറിൻ്റെ അടുത്തേക്ക് കൊണ്ടുചെല്ലുകയാണ്. Then immediately what happens in the metal sphere? We know that the metal sphere consists of equal number of positive charges and negative charges as it is neutral. Now the spheres are in contact with each other, so they act like a single body. So when we bring the charged rod near to the metal sphere, what happens? The charges inside the spheres get separated and the positive charges are induced on one side and negative charges on the other side of the sphere. In the third step, in the presence of charged rod, the spheres are separated. Now you can see that the spheres are separated and they are not in contact. In the fourth step, we are removing the charged rod. On removing the charged rod, the charges on spheres rearrange themselves. Now you can see the position of charges, they rearrange themselves. In the fifth step, the spheres A and B are separated to a greater distance and the charges distributed uniformly over the surface. ചാർജസ് ഒരുപോലെ യൂണിഫോം ആയിട്ട് സർഫസിൽ സ്പ്രെഡ് ഔട്ട് ആയിരുന്നു. Now both the metal spheres get charges equally and oppositely. Now how can we detect the charge on a body? Is there any device to detect the charge on a body? We said that the plastic comb has got some charge, the metal sphere has got some charge like that. What is the device used to detect the charge on a body? That is the electroscope. Electroscope is a device to detect the charge on a body. Here you can see a simple paper electroscope. We have a copper metal rod and one end of this rod is attached with two thin paper strips. Take a hole in a cardboard and insert this through this hole and fix it in a bottle. Then rub a PVC pipe with wool and then the charged PVC pipe touches the metal rod. Then what will happen? The charge flows onto the leaves and they diverge. When a charged object touches the metal, the charge flows onto the leaves and they diverge. The degree of divergence is an indicator of the amount of charge. This is how the electroscope works. Next we will see some properties of charges. The first one, additivity of charges. The total charge on a body is the algebraic sum of all the charges located anywhere on the body. That means if a body contains two charges Q1 and Q2, then the total charge of the body is equal to Q1 plus Q2. Also, charge is a scalar quantity. That means it has no direction but magnitude only. So, it can add up like real numbers. Here you can see one example. If a body has charges plus 2q, plus 7q, minus 3q and minus 8q, then the total charge on the body is equal to minus 2q. The second property of charges is the conservation of charges. The principle states that the total charge of an isolated system remains constant. Charges can neither be created nor be destroyed. When we rub two bodies, one body gains charge and the other body loses charge. That means the charges may get redistributed. However, the total charge remains constant. It is not possible to create or destroy a charge. The third property of charge is the quantization of charge. That is, the total charge on a body is the integral multiple of basic unit of charge. Basic unit of charge means the charge of proton or the charge of electron. Charge of a proton is positive, so it is written as plus E, and the charge of electron is negative, so it is minus E. So Q is equal to plus or minus NE. So the total charge on a body is equal to plus or minus NE, where N is an integer, that is N is equal to 1, 2, 3, etc. If a body is charged positively, it can be plus 1E, plus 3E, plus 5E and so on. If the body is a negatively charged body, it can be minus 1E, minus 2E, minus 3E and so on. But it cannot be 3 by 4E, minus 3 by 4E and so on. And the value of E is 1.6 into 10 raised to minus 19 coulomb. If it is proton, the charge of proton is plus 1.6 into 10 raised to minus 19 coulomb, and the value of electron is minus 1.6 into 10 raised to minus 19 coulomb. The charge is represented by the letter Q, and the SI unit of charge is coulomb. Also, charge is a scalar quantity. Now let us do one problem. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 raised to minus 7 coulomb. Estimate the number of electrons transferred. We have total charge Q is equal to minus 3 into 10 raised to minus 7 coulomb. The charge of the electron is equal to minus 1.6 into 10 raised to minus 19 coulomb. We have the equation Q is equal to NE. Therefore, N is equal to Q by E. That is equal to minus 3 into 10 raised to minus 7 divided by minus 1.6 into 10 raised to minus 19 is equal to 1.875 into 10 raised to 12 electrons. Thank you.